Hi guys, my name is Rahul. I welcome you to the chapter 2 of data analysis series. So in the first chapter what we have seen is what do you mean by data, what are the different data types, methods, quantitative data, qualitative data. So if you have not watched those, I would request you to watch that. The video link is in the description. So let's not waste much of our time. My name is Rahul and we are in the second chapter of the data analysis series. Now in this I will be telling you about the details of the project which we are going to do. So the project which we are going to do is loan approval prediction. The project title is loan approval prediction, of course, and these are the problem statements. Loans are the major requirements of the model world, and you can go on read all these. Alright. So the dataset overview, something looks like this. The first column we have loan ID, which is unique for the entire people. The gender, male and female, married, yes or no, dependents, 0 or 1, education, self-employed, applicant income, co-applicant income, loan amount term, credit history, property area, and loan status, that is Y or N. Now this is our dependent variable and all other columns are independent variables. Now let's look for the dataset attributes. Now what do you mean by loan? Loan is an unique ID. Gender we know, married status, marital status we know, dependent it tells whether the applicant has any dependents or not. Education, it will tell us whether the applicant is graduated or not. Self-employed, self-explanatory. Applicant income, self-explanatory. Co-applicant income, so co-applicant income states that whether a person has given some applicant details and if that applicant has some income or not. Loan amount, how much loan amount he has taken in thousands. Loan amount terms, which he has taken for how many months. Say for example, if it is 360 months, that is 360 if it is mentioned, that is 360 months. Credit history, how is the credit history and debts. Property area, where does his property area lies, rural, urban or semi-urban. And the loan status is our dependent variable, that is Y is equals to yes, N is equals to no. Programming languages and IDEs for data analysis. IDEs are integrated development environments for data analysis. Now Python is preferred language for data analysis due to its versatility and extensive library support. Python boasts an extensive ecosystem of libraries with pandas, numpys and matplotlib being essential tools for data analysis. Apart from pandas, numpy, matplotlib, we also make use of Seaborn, sklearn for model training, and then pre-processing for pre-processing, normalization, standardization and all. There are loads and loads of libraries which are present in Python. That's why we prefer Python over any other IDEs or any other programming languages. IDEs which I personally use is Jupyter Notebook, but you can definitely go for Visual Studio or Google Colab for that matter. Preferred integrated development environment IDEs are Google Colab, Anaconda, that is Jupyter Notebook, which we are going to use, and then we have Visual Studio Code, VS Code, as we properly use it. Python modules for data analysis. Now there are several modules like libraries, also called as libraries of Python, provides robust tools for data manipulation, visualization and machine learning. Here are an overview of 4 key Python modules used for data analysis. First is Pandas. Pandas is an open source data manipulation and analysis library that provides data structure and functions needed to manipulate structured data seamlessly. It is built on top of NumPy and offers true primary data structure, series and data frame. Pandas is majorly used for loading the data and all the performance, all the necessary evaluation which can happen on the data frame. Key functionalities of Pandas include input and output, supports reading and writing the various data file in the format of CSV, Excel and some more. Indexing and selections provide powerful tools for selecting and filtering specific data subsets. Data cleaning, handling missing data, removing duplicates, handling outliers. Data transformation like merging, joining, concatenating and reshaping and pivoting. Data aggregation like grouping, summarizing and computing statistical measures. Now, how do you install Pandas? If you have not installed Pandas, you run a command called pip install Pandas. It will take some while to install, depending on the internet speed. It will get installed. Importing Pandas. How do you import Pandas? Now we import Pandas. Since I don't want to write Pandas again and again, so we give alias as Pandas as PD. So anywhere if I want to call Pandas, I would just write PD. Pandas data structure. Now it has two data structure called series that is one dimensional labeled array, that is series and data frame. So series has one dimensional labeled array. It is homogeneous, which means it contains data of the same type. Indexing and labeling is at ease. Like this is a typical example of it. Now where the first column indicates the index, which is not a column, so it's only one dimension labeled array. So that is the values are 25, 50, 75 and 100. Definitely the data type of it is int. Whereas data frame is two-dimensional tabular structure. It is in the format of matrix. Whereas it is heterogeneous. Columns can hold different data types, of course. Size is mutable, as in like I can change the data, I can change and update the data as per my wish. Now this is a typical iris data set which has multiple columns. It is two-dimensional tabular structure. You can see in the sepal length, sepal width, petal length, petal width, and its class. Alright, so this is our typical data frames. So majorly in 99.99% of the case, you will definitely, apart from time series analysis, you will definitely go for data frames, as you will encounter multiple columns as a two-dimensional table structure, and you have to find the insights out of this. Python module for data analysis. Second is Matplotlib. Matplotlib is widely used Python libraries for creating static, animated, and interactive visualization in Python. It provides a wide variety of charts and plots. It offers a high degree of control and customization over the visualizations. Now, how do you import Matplotlib? That is, import Matplotlib. From that entire library, I would only require pyplot. So from Matplotlib, I would import pyplot, and I would want to give the alias for pyplot as plt. So that's why I'll import matplotlib.pyplot as plt, or you can also write it as from Matplotlib import pyplot as plt. Seaborn is built on top of Matplotlib and offers a high-level interface for creating informative and attractive statistical graphs. Now, you must ask this question, that when data visualization was happening from Matplotlib, why there was a need of importing Seaborn? Seaborn is already built on top of Matplotlib, so both are used for data visualization. But in order to make the charts more appealing, in order to make the chart more easily gives us insight, we import Seaborn, because Seaborn is the latest and gives you more complex visualization. It particularly useful for statistical data visualization. Now, how do you import Seaborn? Import Seaborn and the alias as SNS. Now, the fourth one is scikit-learn. Now, scikit-learn is a machine learning library in Python that provides simple and efficient tool for data mining and data analysis. It is built on top of NumPy, SciPy, and Matplotlib. Now, what are the key features of scikit-learn? Is supervised learning, algorithm for classification, predicting categories, and regression, predicting continuous values. Unsupervised learning, algorithms for tasks like clustering, grouping similar data points, and dimensionality reduction, compressing data. Now, clustering, we have k-means clusterings, agglomerative, we have divisive, we have db scan. So we have different knn. So we have different algorithms which is used for clustering. Whereas for dimensionality reduction, we use principal component analysis. Model selection and evaluation, tools for comparing different models, tuning hyperparameter tunings, and accessing model performance. Pipeline, streamlined data preparation, model training and evaluation. Wide range of algorithms, implementing wide range of algorithms, various algorithms for different tasks, including decision trees, support vector machine, random forest, and many more models we can import from scikit-learn. So thank you guys. This was it from the second chapter. I hope that you guys have watched second chapter. So in the next chapter, what we are going to do is we are going to have a hands-on experience of model building from scratch till model building. So I hope to see you in the next video. If you have not subscribed, I would request you to subscribe. I'll meet you in the next video. Till then, take care. Bye-bye.